Hi everyone, let us discuss this example. In this example, we have to find a value of surface integral of a vector field. Okay, so let me write the definition of surface integral of a vector field. So the definition says, let me write, we know that double integration of f over s. So f is a vector field and s is a surface. So this is equal to double integration f of, let me write here, f of phi of uv. Phi is a parameterization of surface S which is defined on domain D. So that's why we solve this double integration over domain D. So what we do after that, we find partial derivative of phi with respect to u, partial derivative of phi with respect to v. We take their cross product and we take the dot product of this bracket with f of phi of uv. Okay, and du dv. So this is definition of surface integral of a vector field. So we have to find out all these values, and by solving the double integration we will have the required answer. So let us write what is the given information. What we have a vector field. So let me write here, we have what they have given to us, the vector field f of xyz, it is defined as 18z, right, minus 12 only and 3y. So let us focus on a given surface now. What we have, S is a surface. So simply I will mention S is defined as 2x plus 3y plus 6z is equal to 12. Getting? And the most important thing is they are mentioned in a first octant. That means we have to consider that part of surface which lies in first octant only. So let me mention in first octant. Okay. So x, y, z having power 1, that means it represents a plane. We have a plane, okay, and we have to consider only that part of plane which lies in the first octant. So let me draw the diagram so we can easily find its parameterization. This is z-axis, this is y-axis, and this one is x-axis. Okay, so let me write some scaling here. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so let us see what I am going to do. I am going to put y and z 0. If I put y and z 0, you will have 2x is equal to 12. What will you have? 2x is equal to 12. That means x is equal to 6. So that plane cuts x-axis at point 6, 0, 0 at this point. Getting? So after that we want the point of intersection of that plane with y-axis. So this is x-axis, this is y-axis, and this is z-axis. To find a point of intersection with y-axis, what will I do? I am going to put x and z 0. If I put x and z 0, we will have 3y is equal to 12. 3y is equal to 12. By solving it, we will have y is equal to 4. So that means that plane cuts y-axis at point 0, 4, 0. Here, 0, 4, 0, right? And to find a point of intersection with z-axis, I am going to put x and y 0 to 6z is equal to 12. That means z is equal to 2. So here z is equal to 2, 0, 0, 2. So if you consider the part of plane which lies in the first octant, so we will have shape like this. Okay, just a minute, let me join. Yes, we have a shape like this. So this type of triangular region we got, okay, triangular region we got in first octant, right? So this shape we have. So after that what we have to do, we have to find its parameterization. Okay, so let me denote it properly first. What we have, this is, let me write an equation, 2x plus 3y plus 6z, right? Yes, is equal to 12. So we have to find its parameterization. That means what we have to do, we are trying to express the surface with the help of two variables. So for that I am going to take the projection of this triangular region, okay, in xy plane. I am going to take its projection in xy plane. So let me draw the diagram in xy plane now. So this is y-axis and this one is x-axis, okay. Yes, this is a scaling, this type of scaling we have. So see, if I put z is equal to 0, we will have 2x plus 3y is equal to 12. What we are doing, we are taking the projection in xy plane, right? xy plane, xy, what is the equation of xy plane? Z is equal to 0. So that's why I am putting z is equal to 0 here. So 2x plus 3y is equal to 12. Getting? 2x plus 3y is equal to 12. So let me write here 2x plus 3y is equal to 12. So that line we get there, getting. So if I put y0, so 2x is equal to 12, that means x is equal to 6. So it cuts x-axis at point 1, 2, 3, 4, 5, 6. So 6, 0 in xy plane I am talking, getting. And if I put x0, here, 3y is equal to 12. That means y is equal to 4. So it cuts y-axis at point 0, 4. So let me join them, this type of triangle. So if you take this projection of this cross plane on xy plane, then we will have a triangle like this. We have a triangle like this. X-axis equation y is equal to 0, y-axis equation x is equal to 0. So this type of region we have. Let me highlight in this way. Just a minute. Yes, so this type of region we have. Okay, that's it. So let us find its parameterization. Now it is very easy task. So yes, so I have taken the projection in xy plane. That means I am trying to express the entire region or the parameterization with the help of two variables only, x and y. Then let me mention, then parameterization of S is, we denote it by phi. So phi of xy, since with the help of xy only I am going to express the entire region. So x, y, but for z what we have to write? See, what is the equation of this plane? 2x plus 3y plus 6z is equal to 12. That means if you simplify it, let me show you. If you simplify it, let us see what will you get. See, in the rough I am going to do this. So what is the equation I have? 2x plus 3y plus 6z is equal to 12. So let us shift the remaining two variables on that side. So 6z is equal to 12 minus 2x minus 3y. Agree? Let us shift 6 on that side. So z is equal to 12 minus 2x minus 3y divided by 6. Okay. So this is value of z. Using this equation of plane, I got the value of z. So that value of z, that means simply I express z in terms of x and y. So that value of z I am going to put here. So 12, okay, let me write properly. So 12 minus 2x minus 3y divided by 6. So this is the parameterization, okay. So let me remove that rough part, okay. So now the most important thing is limits of x and y. So in xy plane we have this triangular region. So you know well, when we have a region in xy plane, what we do to find the limits? We draw a strip. We have two options, either we draw a strip parallel to y-axis or we can draw a strip parallel to x-axis. I will go for a strip which is parallel to y-axis. This type of strip we have. So let us find the limits of y first. The strip is bounded below. We have a simple funda. We have already studied that part in double and triple integration. So strip is bounded below. So bounded below, bounded above and left to right. We have to move the strip to cover the entire region. Okay. So strip is bounded below by y is equal to 0. So the lower limit is 0. The strip is bounded above by this line whose equation is 2x plus 3y is equal to 12. So what will be the value of y? Using this equation, by shifting 2x on that side and dividing by 3, we will have y is equal to 12 minus 2x divided by 3. So these are limits of y. So now we have to move strip from left to right. So at left, it will start at y-axis whose equation is x is equal to 0. So x is bounded below by 0. So here we have to move this strip slowly like this, and it will go up to that end point, corner point, where the value of x is 6. So x will vary from 0 to 6. So finally we got a parameterization phi. See, we got a parameterization. After that we have to take its derivative with respect to x. Here I have written u and v variable I have considered, but now we have x and y. So I should take derivative with respect to x, with respect to y, cross product, its value, and then dot product. Okay, I am going to do all these things. Just we want some more space to write, so make a screenshot of it, then I will go further. So let us find derivative of phi with respect to x first. So yes, okay, so what will I do? I will simplify it first, so it will be better getting. So x, y, what will I do? I will divide separately, then calculations will be more easy. So 12 by 6 2, 2x by 6, that means x by 3, and if you divide 3y by 6 it will be just a minute, minus y by 2. So now it is easy. I hope it is visible to you. 2 minus x by 3 minus y by 2, right? Okay. So let us find the partial derivatives. Then derivative of phi with respect to x. Derivative of x with respect to x, 1. We are differentiating with respect to x, so that's why y's constant derivative will be 0. Here minus sign is there, we can take separate derivatives. Derivative of 2 is 0 since it is constant. We are differentiating with respect to x, derivative will be minus 1 by 3, and y by 2 is a constant, again derivative will be 0. So now derivative of phi with respect to y. Derivative of x 0, since we are differentiating with respect to y, it will be constant. Derivative of y 1, and 2 minus x by 3 is constant, since we are differentiating with respect to y, derivative will be 0, and here we will have minus 1 by 2. After that, what we want their cross product. Let us do that. Then phi x cross phi v. So you know well how to find the value of cross product by solving a determinant. So determinant I, j, k, phi x, okay, its coordinates are 1, 0, minus 1 by 3, and phi y, which is 0, 1, minus 1 by 2. So let us solve this determinant I. Product of these two, 0, minus product of these two, minus plus 1 by 3, minus j, product of these two, minus 1 by 2, product of these two, 0, I will not write that thing, plus k, product of these two, 1, and 0 into 0, 0. Okay, so it will be 1 by 3 minus plus 1 by 2 and 1. So this is value of cross product, getting. So after that we have to find its value also, and then we will take the dot product. Okay, so now f of phi of xy we have, okay, phi of xy. So f of, what is our phi of xy? Where is it? Yes, it is here. So let me write here xy 2 minus x by 3, yes, minus y by 2. So I simply put the value of phi of xy there. After that we have to operate capital F. What is definition of capital F? It is here. So definition of capital F says 18 into z, 18 into the last component. I will do the same. So 18 into the last component, which is 2 minus x by 3 minus y by 2, comma, minus 12, it's a constant, it's fixed, so let me write a minus 12, and last 3y, 3 into the middle component, so 3 middle component y, so again we will have 3y. So simply we can solve this bracket, so to make it more simple, so I will multiply each term by 18, so 36 minus 6x and minus 9y minus 12 3y. So in this way we got the value of the first term also. So we got the value of cross product as well as f of phi of xy. Now simply we have to take the dot product, and then we will put all those values here in the integration. Okay, so let me make some space here to solve the remaining part of this problem. So let us find the value of dot product now. Okay, so now we are going to find the dot product of f of phi of xy dot at phi x cross phi y. So let us put the values. The value of f of that thing we have got 36 minus 6x minus 9y, comma, minus 12, comma, 3y dot. Okay, dot product of phi x cross phi y. What we have got here, cross product, yes, here 1 by 3 minus 1 by 2 and 1. So you know well how to find the value of dot product. First component into first component plus second component into second component and the third component into third component. So 1 by 3 into the first term. So 1 by 3, 36 minus 6x minus 9y plus, actually plus is there, but we are taking the product of minus 12 and 2, which will be minus 6, okay. And the third component into third component, that means 3y. So we can simplify this bracket, we can multiply each term of that bracket by 1 by 3. So 1 by 3 into 36, 12, minus 1 by 3 into 6x, 2x, 1 by 3 into 9y, minus 3y, minus 6 plus 3y. So can we simplify it further? Yes, definitely. that minus 3y plus 3y will get cancelled. So let me remove it. That minus 3y and plus 3y cancel, and yes, 12 minus 6 we can write 6. So it will be 6 minus 2x. 6 minus 2x. Okay. So now I'm putting all those values in this definition now. Okay. So yes, double integration f over s is equal to double integration. So the value of dot product is also ready. So its value is 6 minus 2x. So simply put it here, 6 minus 2x. We have dy dx. I am writing dy dx. Since you remember, we had considered a strip parallel to y axis. So we should integrate with respect to y first, then we will integrate with respect to x, y. So what is limits of y? Here limits of y 0 to 12 minus 2x by 3. Same limit I am writing here, and limits of x 0 to 6. So simply we have to integrate it. Okay. So make a screenshot of it first, then I will go further. So let us simplify it further. So double integration f over s is equal to, see, we are solving this one. First we are integrating with respect to y. So 6 minus 2x is constant, will come outside. So integration 0 to 6, and that 6 minus 2x will come outside. Integration 0 to 12 minus 2x by 3, right? And dy only, and after that dx. Okay. So this is equal to integration 0 to 6 minus 2x. Integration of dy is y 0 to 12 minus 2x by 3 dx. After that, what will we do? We will put upper limit, lower limit. So this is equal to integration 0 to 6 minus 2x. I am putting upper limit. So 12 minus 2x by 3. And if you put lower limit 0, we will have 0. Okay, we have some space, let us use. Okay, I am going to write the remaining part of this problem here. Okay. So to make the calculation more simple, what will I do? I will take the constants outside. So from the first bracket, definitely we can take 2 common. So 2 is a constant, so that's why I am taking it outside. 0 to 6. So if you take 2 common, we will have simply 3 minus x, right? And from the second bracket, from numerator we can take 2 common, and 3 is already common in denominator. So that 2 by 3 I am taking common, 2 by 3. So if you take 2 common here, 6 minus x, and 3 already we have taken outside, dx. So it is 4 by 3 integration 0 to 6. We will solve the brackets, we will multiply. Okay, 3 into x, this minus 3x. Yes, okay, first I should multiply. I should take the product of 3 and 6. It is 18 minus 3x, 6 into minus x, minus 6x, minus plus x square. So this is equal to 4 by 3 integration 0 to 6. We have x square, okay, minus 3 minus 6x minus 9x plus 18 dx. Now it is looking simple. So what will I do? I will integrate, okay. Addition, subtraction is there, we can take separate integration. Integration of x square is x cube by 3. Its integration will be 9x square by 2, and it will be 18x 0 to 6. Now I will put upper limit and lower limit. So it will be 4 by 3, 6 cube, that means 36 into 6 by 3, minus here 6 square, that means 9 into 36 by 2 plus 18 into 6. Okay, and if you put 0, we will have 0. What will I do? I will try to take some common part to make the calculations more simple. So 4 by 3 as it is. Can we take 6 from all sides? Yes, definitely we can take 6 common from everywhere. So 6 I am taking common. So 36 by 3, that means it is 12. Okay. Here I am taking 6 common, that means 9 into 6 by 2. Here also I am taking 6 common, that means simply 18. So here 3 will get cancelled, 4 into 2, okay. So 12, here 2 to cancel, that means 9 into 3, 27, and this plus 18. So it is looking simple now, 8. So what will be the sum? 12 plus 18, it will be 30 minus 27. So it is 8 into 3. So the final answer is 24. So this is a required answer. Okay. So make a screenshot of it, then we will stop. See you.